attention is shifted from the rings toward the known moons of Saturn. Mimas is the innermost of the larger Saturn moons, with an enormous crater, 80 miles wide and 6 miles deep. Mimas is thought to be frozen solid. Tethys, a moon scarred by a crater large enough to hold Mimas, and an ancient chasm more than 1,500 miles long. Dione, a moon with bright radiating patterns on one hemisphere and an underlying presence of craters. Rhea shows an icy face to the cameras. Bright streaks are probably fresh ice ejected from beneath its crust. Enceladus, an extremely bright moon that reflects more than 90% of the sunlight that falls on great plains of ice. A closer photograph reveals that it may be a recently active moon with internal heat that melted the surface. Iapetus, the outermost of the larger moons. The dark side contrasts sharply with a lighter trailing hemisphere, an oddity for which there is no present explanation. And Hyperion, an apparent fragment from the shattering of a larger moon, tumbling erratically in its orbit. The most intriguing of Saturn's moons is Titan, larger than the planet Mercury. It is the only moon known to have an atmosphere. Nitrogen and methane gases shroud Titan with dense clouds which our cameras cannot penetrate. The chemistry of this atmosphere is unlike that of any other. If we could descend to the surface of Titan, we might see ice mountains softly eroded by a persistent rain of complex chemicals, and a deep chemical ocean, a strange parody of the oceans of Earth. Titan's atmosphere, like the ancient atmosphere of Earth, contains pre-life chemicals, but is too cold for life to evolve. The moons of Saturn have a direct influence on Saturn's rings. A natural tendency of ring material is to spread both toward and away from the planet. But the moons, in a complex interplay of gravitational forces, shape the rings and define their structure. Four and 1/2 billion years ago, the planets were formed in the gravitational collapse of a great cloud of swirling gas and dust. In that collapse, the gravitational energy of this gas and dust falling inward heated the planets as they formed. Jupiter and Saturn have not yet cooled off. Consequently, both planets give off more energy than they receive from the sun. And this energy is thought to be the heat engine that yields the stormy patterns of their intricate weather systems. An experiment has been performed which demonstrates how these weather systems could work. The major planets can be regarded essentially as rotating fluid spheres, which are heated from within. In the laboratory, this is simulated by a rotating sphere assembly. When instability is induced, long, thin columns are formed in a series of ever larger shells or layers. The layers create wind flows moving at different speeds, and the tips of the columns form the familiar bands of Jupiter's clouds. If this is what happens, and there are competing theories, it could change our understanding of weather systems on these giant planets. Jupiter and Saturn have dozens of storm systems. On Jupiter, the white ovals are smaller versions of the Great Red Spot. The red spot is larger than several Earths and rotates in 6 days. This violent storm has existed for at least 300 years. Its center is quiet, but the outer rim seizes clouds and smaller storms and whips them around the edge of the spot. A series of blue filter photographs assembled to form a movie of the red spot enables scientists for the first time in centuries of observation to study the storm's motion in detail. Saturn's atmosphere appears similar to Jupiter's, with alternating dark belts and bright zones, alive with eddies that swirl and dissipate their energy into atmospheric circulation. It is the summer of 1981. As Voyager 2 flies behind Saturn out of sight of the tracking stations on Earth for 2.5 hours, the movable camera platform jams and stops. When the spacecraft appears from behind Saturn, it is programmed to again transmit photographs. But in place of images, only blank frames are displayed on the monitors. The platform is obviously not pointed where it should be.
It's not there.
All the instruments on the platform are put into a standby mode, and project engineers begin to analyze the problem.
Thing was supposed to scan.
2 days later, engineers find that with care, the platform can again be commanded to move. Despite the fact that Voyager is 1 billion miles from Earth, engineers are able to pinpoint its problem and successfully restore the platform to use. An image reappears on the monitor screen, and the final photographs of Saturn and its rings are sent to Earth.
There's a shadow across it.
Oh, yeah. Ellis has drawn what you should be seeing.
The frame's upside down.
August 1981. Voyager 2 recedes from Saturn on its journey to Uranus and beyond. The recent discovery of 9 rings encircling Uranus and its 5 known moons hold the promise of fresh discoveries. And in 4 more years, Voyager 2 will reach that planet. Three years later, it will reach the 8th planet, Neptune, and its great moon, Triton. Meanwhile, Voyager 1 will continue its flight, searching for the unknown edge of the influence of the sun, where interstellar space begins and our sun is just another star in the sky.